Hello again, this is Mr. Wakefield, and we are looking now at not just square roots, even though it says that at the top of the page, but all kinds of roots and the radicals that go with them. We'll start out with square roots, though, since those are the most common ones. Basically, what a radical is, okay, is it's the opposite of an exponent, okay? So if you take the square root, as we call it, of 25, okay, we'll say that that's equal to 5. I'll explain that in a minute. But that's the opposite of taking 5 to the second power. Okay, so that's why they call it a square root, because 5 squared is 25. This is a separate problem here, two separate problems here. Okay, so 5 squared is 25. Square root of 25 is 5, going backwards. Now, here's the thing that we got to be careful of. It is also true that negative 5 squared is equal to 25, but you do not say that this is equal to negative 5. I'll get into that more in a second here, but when we take the square root radical, and we actually have this radical symbol with the number underneath, they are looking not for the negative answer, but only the positive answer, even though in a lot of cases there will be two different possible numbers that will give you that number underneath when you square it. Because that's what we're doing. Okay, when you have a radical that's a square root radical in particular, you're asking what number do you square to get that number underneath? Well, it's 5. It's also negative 5 theoretically, but the radical, when you see that radical, please remember that they are only looking for the positive answer. Okay? So when you have a square root radical, all right, with a positive number underneath, and we'll talk about when it's not positive, okay, this is going to be what? This is going to be the positive square root, okay, that they're looking for. Okay. Now we have other types of roots as well. We'll get into that here, but first of all, let's take a look at this down here. What is this asking for here? And it says evaluate. Evaluate, by the way, just means to find the value of it, to figure out what it's equal to. They are asking for the square root of 49, but since it's a square root radical, that radical symbol is telling us that they only want the positive answer. So yes, it's true that 7 squared is 49. It is also true that negative 7 squared is equal to 49, but because that radical, that square root radical, tells us it only wants a positive answer, we're only going to say 7. Okay? So that's the thing, you guys. We have other types of radicals as well. You can see down here that we have the 4th root of 81. That's the same thing as a square root, except for they're asking for what number do you take to the 4th power to equal the number on the inside, which is 81. Okay. Here they are asking for what? Because it has that little 5 right there in between that little V shape in the radical. Okay, that little 5 means what number do you take to the 5th power that equals 32? And that negative sign is separate. Well, I'll talk about what that means in just a minute. Okay, when we get to that problem. But and in the same way, over here, okay, they are asking, because that's a little 3 right there, they're asking what number to the 3rd power is equal to the number on the inside, 27. Okay, now here's the thing, okay, when that number that's inside the V is even, and even like meaning 2 or 4 or 6 or one of those numbers, an even number. Okay, and whenever you have no number there, that's implied that there's an invisible 2 right there. We have a lot of invisible things in math. Okay, this is one of those cases. There's an invisible 2 right here. When there's nothing there, it's a 2. Otherwise, if it's any other number, then that number will be written there, like the 4 or the 5 or, like I said, the 3. Okay, when that number, invisible or not, when that number is even, they only want the positive answer. Okay, when that number is even in the V, they call that the index number or the root number. Okay, whether it's 2 or 4, okay, again, this would be 2, right, because it's invisible. This is 2 as well, okay, and this one's 2. Square roots are very common. That's why I have a lot of those examples. Okay, those ones are only, you're only supposed to give the positive answer. Okay. Whereas when it's an odd number, such as 3 again, or 5 again, in that case, there will always be only one possibility, and so you just have to find it. Okay? Doesn't matter what the thing is underneath. The thing underneath the radical could be negative. It could be positive. It does not make any difference. Either way, there will always be only one possibility. Okay, there'll never be less than 1. There'll never be more than 1. Okay, unlike here where there were 2 possibilities for 49, 7 and -7, but we were supposed to only give the positive answer. Okay, with the odd numbers, there will always be only one possibility. So it makes it real simple. You just got to find it, and then you know you have it. Okay, once you find it, because there's only one. Okay, so even roots, let's write that down. Okay, when it's an even root or even index, okay, then that's going to be just the positive, and then we call it the fourth root. It's the number that you take to the fourth power to equal the number on the inside. Just the positive. However, when you have a cube root, as they call it, when it's a little 3, or a fifth root, when you have the little 5, that is going to be what? That is going to be whichever number you get. It's going to be the third root, okay, or the cube root. I'm sorry, I didn't mean to say third root. Okay, that's not wrong. It's just a cube root. It's a more common way of saying it. Cube root or fifth root. Okay, but the point is that it could be either positive or negative. Okay, there'll always be one answer. Okay, always one possibility, no mystery. Okay, it's not like with the square roots where it could be 2 possibilities. Always one possibility. Okay, and it could be what? It could be either positive or negative. Either positive or negative. Okay. So let's get into it here, all right? So with square roots and fourth roots, I'll jump down to this problem just to keep with that same theme where you can only have one answer, okay, even though there's 2 possibilities. Here, 7 and -7 squared equal the number underneath, 49, but we don't want the negative answer, right? We just want the positive answer. It's the positive number that when you square it, it's equal to the number on the inside. Same thing here when that is fourth root, because that's an even rooted radical. Okay, we're just going to do 3. It's also true that -3 to the fourth power is equal to 81. That's also true. But because that's an even root, we don't want that one right there. Okay, we just want the positive answer. Once again, this is a square root. But this is a little bit different because of the minus sign. When you have a minus sign at the beginning of the problem, you guys, followed by the radical, and then that's it. There's nothing after the radical. That means this. That means -1 times whatever the radical is equal to. Okay, and remember, you compute, as part of order of operations, you compute radicals before you multiply. So we're going to calculate what the radical is first, then we'll multiply that answer by -1 to get the final answer. Now the radical, okay, is 121 underneath. So they want to know what number do you take to the second power, because it's a square root, to equal 121. Okay, that would be 11, right? It's also equal to -11, okay? But again, we don't want that. We don't want the -11 because it's a square root radical. It's an even rooted radical. Square means 2. Okay, and so they just want the positive answer. So the radical, not including the negative, that's outside of the radical. That's separate. Okay, the radical itself has to be a positive answer. It's 11. Okay, so the radical is just 11. But then, since the negative was separate and since we have to multiply after computing the radical, the final answer would then be -11. So it's still true that the square root radical has to be the positive answer, okay? But because that negative was on the outside and we compute that after the radical, that's what made the final answer negative. But the radical is still positive, okay? Now there is one exception to this idea that you're going to get a positive answer whenever you have a square root or a fourth root. Okay, sometimes you don't get any answer at all. But if you do get an answer, it would have to be positive. Now, when do you not get an answer? Okay, you don't get an answer when the number, and I'm just talking about even roots here. If you have an odd root, you'll always get one answer, like I said a few minutes ago. You will always get an answer, okay, whether it's positive or negative underneath, it does not make any difference, okay? But with even rooted radicals, okay, a negative, all right, will always give you what we say is not a real number. When we say not a real number is because later on, okay, in a future discussion, we'll learn that there is an imaginary answer, not a real answer, but an imaginary answer. There's real numbers, which are the numbers that we're normally used to, you guys. It's the, it's the whole numbers and the negative whole numbers and all the decimals that go in between and all the normal fractions that we have as well. Okay, but imaginary numbers are a whole separate thing. Again, you don't need to worry about that here in this current video, but that discussion will come later, and we'll talk about when you need to be aware of that. But for now, when you get an even-rooted radical, you guys, whether it's a square root, fourth root, or whatever, if it's negative underneath, there's just no answer. We say not a real number because there is an imaginary answer that we'll learn about later. You could say for the moment anyway, just no answer is fine to say that, but officially it's not a real number because there is an actual imaginary answer that we'll learn about later. Okay, so to review here with even-rooted radicals, if you have anything other than a negative number underneath, a positive number or zero, okay, you're going to get the positive answer only. There will be an answer in that case, and it will be a positive answer only. If you have an even-rooted radical with a negative number underneath, then there is no answer. Now, with odd radicals, okay, again, a lot simpler. There's always going to be one answer. You just got to find it. You'll never have two possibilities. Okay, you'll never have a situation where there is no answer. It'll always be just one answer. Okay, so let me just go ahead and finish up though with the even-rooted discussion. Notice there's a variable on this one. Okay, now I'm going to remind you. And I'm just taking this from a separate video where factoring was done. Remember, you're trying to figure out what's taken to the second power to equal the thing underneath. Now, I know there's no radical here, but it's the same idea. They wanted to know what you take to the second power to equal this term right here. They wanted to know what to take to the second power to equal this term, and they figured out that 5x squared was that thing. Okay, so when you have a variable, we're going to do a similar thing here. Let's take a look. We want to know what? We want to know what is taken to the second power, and it has to be positive because this is a square root. So we're looking for the positive thing. But similar to this here, okay, what did we do right here? We said, okay, what is taken to the second power to get 25? And then since you, when you have a single term in a bracket taken to a power, remember that's when you multiply the exponents. These are multiplied, not added, even though it would be the same answer. They're officially supposed to be multiplied. Just like I hear 3 times 2 is 6. 2 times 2 is 4. So in the same way, okay, what number do you take to the second power to equal 36? Again, it's got to be positive. That would be 6. Okay, looking at 36 here. Then we look at the x to the 8th, and 4 times 2 is 8, and so x to the 4th must be the correct thing to put in there to match up with x to the 8th. Okay, so the answer is 6x to the 4th. Yes, it's true that negative 6x to the 4th would also equal 36x to the 8th, but again, we only want the positive answer because it's a square root. Okay? So that's why that's 6x to the 4th. And just an additional practice here, okay, if they said, hey, what's the square root of 9y to the 6th? Even though this is a separate worksheet, I'm just going to write this down here. The square root of 9y to the 6th would be equal to 3y to the 3rd because 3y to the 3rd taken to the second power is equal to 9y to the 6th. Okay, that is the positive term that when it's taken to the second power is equal to the thing on the inside. That's what square roots are all about, right? Square root radicals are the positive thing, if it exists, okay? As we saw a few minutes ago, sometimes it doesn't. The positive thing, you're looking for the positive thing that when you square it, square the whole thing, that's why I put brackets around that, square the whole thing, it is equal to the thing on the inside. So when you're trying to figure out what's being squared, use parentheses like I do on all of these here, just to make sure that what you're testing out, you're squaring that whole thing. Because it's supposed to be whatever you choose is the answer. That whole thing has got to be equal to the inside. So we put a bracket around it to make sure you're squaring the whole thing. So that is even-rooted radicals. Let's look at the odd-rooted radicals here. Okay, let's start out with problem D. What thing do you take to the third power that's equal to negative 27? Okay, that would be negative 3, and I know that because it's negative 3 multiplied 3 times. Negative 3 times negative 3 is equal to 9, right? But then if you multiply it a third time, it's equal to negative 27. Now, some of you might be thinking, as I write down the answer here, some of you might be thinking, hey, wait a sec, what about 3? Why doesn't 3 work? 3, if you cube that, it's equal to positive 27. See how that doesn't work? Okay. 3 times 3, and then you multiply 3 a third time, that would be equal to positive 27. And so that's why there's only, like I said, with the odd-rooted radicals, there's only one answer, because if you do the other sign, it'll be a different answer. Okay, you may have noticed by now, and you'll see this in the next couple problems, when you have an odd-rooted radical, if the thing on the inside is negative, the answer is going to be negative as well. This is only for odd roots, okay, not for the even. The even-rooted, obviously, we're always looking for the positive answer no matter what, okay, if it exists, okay. But with the odd roots, if the thing inside is negative, so is the answer. If the thing on the inside is positive, guess what? The answer is going to be the same sign, positive. Okay, so, and again, I'm keeping the negative sign separate here, just like in problem B. Okay, this is separate from the radical. I was just talking about the radical when I said that if the inside's positive, so will the answer to the radical. Not to the entire answer, including the negative on the outside, but just the radical. So if the inside of the radical is positive, so will be the answer to the radical. Okay, what do we take to the fifth power to equal 32? Well, guess what? It's equal to positive 2. It's not equal to negative 2. Okay, because if you did negative 2 to the fifth power and you multiply negative 2 5 times, you can try it if you want, it is equal to negative 32. Okay, and so that would be bad. Okay, we don't want that. So once again, it just shows what I was just talking about, where if the answer on the inside, if the number on the inside is positive, then because this is an odd root, the radical will also be equal to a positive. So the radical is equal to positive 2. However, because we still have that negative on the outside, negative 1 times 2, just like I showed you in problem B, you got to compute your radical before you compute the negative 1. Okay. You multiply, and their final answer is negative 2. But the radical is still positive 2 because the inside of the radical is positive. Again, this is just for the odd-rooted one. So you can see there's a big difference in the way we approach the even-rooted radicals and the odd-rooted radicals. One more here. Again, this has a variable. Okay. As always, when they're asking for the cube root and there's no limitation, it's not like even roots where it has to be a positive answer or whatever. Okay, just whatever works. Whatever works, you guys, okay, when it's an odd-rooted radical, such as a cube root. Okay, so we just want to know what thing goes in here that's equal to this, that's equal to the inside of the radical. Okay, well, isn't it true that negative 3 to the third is equal to negative 27? And so for the negative 27 part of the answer, you've got to have negative 3 in there. Okay. And then for the x part, because of the fact that 2 times 3 is 6, x to the second must be the correct thing to put in there. Because again, you have to take negative 3 to the third power, put a bracket around that to make sure you're taking the entire thing, including the negative, just to test to make sure it's equal to negative 27. Then when you get to the variable part, you multiply the exponents, okay, to get 6. And so 2 must be the correct exponent then. So the answer is negative 3x squared. And again, it's okay for it to be negative because it's an odd-rooted radical. Okay. So to summarize here, you guys, when you have, whether you have an odd root or an even root, okay, you're always looking for, you make this bracket, it starts out being empty, and then whatever this little index number is, in this case it's 2, you put the 2 there as the exponent, and then the thing on the inside goes here after the equal sign, and then you just have to figure out what goes in there. The thing you got to remember, though, is that if it's an even-rooted radical, make sure the thing you put in there is positive. Okay, that's the only thing you're allowed to use. Okay, and then that becomes the answer. Okay, that's assuming that you can find that. Okay, because notice over here that this cannot, you can't put anything in here. You might be wondering, why can't I put 6 or negative 6 in there? Okay, if I put 6 in there, it's not going to work, okay? Because if I put 6 in there, a 6 squared, I don't want to make that look like a negative there. There we go. 6 squared is equal to negative 36, but negative 6 squared is also equal to 36, okay? None of them are equal to negative 36, and that's what the problem's asking for. It's asking for negative 36. It's asking for negative 36 after the equal sign. So those are not going to work. That's why there's no answer. Okay, so you're looking for the thing that goes in that bracket. Okay, if it's an even-rooted radical, it's got to be positive. Okay, if the number underneath, assuming it's an even-rooted radical, if it's negative, then nothing's going to work, positive or otherwise. Okay, and then for the odd-rooted radicals, there's always going to be one thing that'll work. Sometimes it'll be positive, sometimes it'll be negative. It's just whatever works. Okay, and so that's how you evaluate radicals. So that concludes this video for evaluating radicals.